Hey guys, welcome back to my channel. Today we'll go through a new video on curve fitting. So what is curve fitting? And let's look into more of its aspects. So let's the topics which we're going through in this video is nothing but introduction to curve fitting, types of curves, curve fitting techniques, applications of curve fitting, problems of different curves. Introduction to curve fitting. Curve fitting is a powerful tool used in many fields to make predictions and inform decision making. At its core, curve fitting involves finding a mathematical model that best fits a set of data points. This can be done using a variety of techniques, each with its own advantages and disadvantages. One of the key benefits of curve fitting is that it allows us to make predictions based on past data. For example, in finance, curve fitting can be used to predict stock prices based on historical trends. In engineering, curve fitting can be used to design more efficient systems by analyzing data from previous designs. By understanding the fundamentals of curve fitting, we can unlock its full potential and improve our ability to make accurate predictions. Now, let's look into types of curves. Curve fitting is a powerful tool used in various fields to make predictions and inform decision making. One of the key components of curve fitting is choosing the right type of curve to fit the data or to fit the data. There are several types of curves that can be used, including linear, quadratic, exponential, and logarithmic. Linear curves are characterized by a constant rate of change and can be expressed as y is equal to mx plus b, where m is the slope, b is the y-intercept. Quadratic curves, on the other hand, have a parabolic shape and can be expressed as y is equal to ax square plus bx plus c. Exponential curves have an increasing or decreasing rate of change and can be expressed as y is equal to a into b to the power of x, where a is the initial value and b is the growth factor. Logarithmic curves have a decreasing rate of change and can be expressed as y is equal to a plus b natural log of x, where a and b are constants. The curve fitting techniques. So it is a powerful tool in data analysis, and there are several techniques that can be used to achieve accurate results. One common technique is least square regression, which involves minimizing the sum of the square differences between the predicted values and the actual values. This method works well for linear models, but it may not be suitable for complex curves. Polynomial regression, on the other hand, can handle nonlinear relationships between variables by using higher order polynomials. However, this technique can lead to overfitting if the degree of the polynomial is too high. Finally, spiral interpolation is a technique that uses piecewise functions to fit curves to the data. This method can produce smooth and flexible curves, but it may not be as accurate as other methods in certain situations. Now, let's look into the applications. So, curve fitting has a wide range of applications like finance, and engineering, medicine, social sciences, etc. etc. In finance, curve fitting can be used to model stock price movements or interest rates. In engineering, it can be used to design and optimize structures or machines. In medicine, curve fitting can be used to help to predict the progression of diseases or the effectiveness of treatments. In social sciences, it can be used to analyze trends and patterns in data such as demographic changes or consumer behavior. Now let's look into a basic problem on y is equal to a into x plus b. So the method of least square, we can fit the curve into the form of y is equal to ax plus b. The x values and the y values has been given below. To solve the solution, the first step to be taken is to take the normal equation, that is y is equal to x plus b, and it is being given by summation y, which is equal to a into summation x plus b into n. So the next step will be equal to summation xy is equal to a into summation x square plus b summation x. So these are two other equations, that is 1 and 2. So we need to construct a table consisting of the values x, y, x square, and xy. And we need to find out the values of summation x, summation y, summation of x square, and summation of xy. Then applying using the necessary equation 1 and 2, we can solve both equations and we get the respective values of a and b. Hence, we get find the straight line is y is equal to x plus b, where we can apply the a value and the b value. Now let's look into the another problem called y is equal to a into x to the power of b. Same. In this also we consider the initial equation, that is y is equal to ax to the power of b. Take log on both sides. So log ey, which is equal to log ea into plus b into log e of x. Now let capital Y, which is equal to log y, like capital A, which is equal to log of small a, the capital X, which is equal to log of small x. Capital Y is equal to A plus B X. Summation, take summation on both sides. So you get the equation. Next, summation HY will equal to A summation H square plus B into summation X. Again, construct table. H, Y, capital H, capital Y, capital H into Y, capital H square. Find the summation of the respective table. Next, apply the respective equations. That is, summation y is equal to a into summation capital H plus b in. Next, summation hy is equal to a into summation of h square plus b into summation h. You get the a and b values. Then use the initial equation, that is log a is equal to capital A, from which you can get the value of small a. And again, finally, you will get the value of y, that is 0.5 into h square. I thank everyone for watching this video. Kindly like, share, and subscribe my future videos. Thank you once again.